All right, we are going to do something similar. We are going to reflect across the x or the y-axis, and when we reflect across the y-axis, that means your x becomes negative, your y stays the same. We're going to do the same treatment that we did for this first problem, and first try to find it through the points. So if I look, I have the same exact points. So I'm going to copy down. I have x and y's. This is the same equation. So I have 0, 2, negative 1, negative 2, and negative 2, negative 4. But when we go to change our graph, it's the x that's changing, not the y. Move this just a little bit up so that this guy can have some more space. There we go. So our x's turn negative, but if x is 0, it doesn't change at all. So that point doesn't move. And then we have positive 1, negative 1, and positive 2, negative 4. So if we graph this out, this point doesn't change at 0, 2. But then we have positive 1, negative 1, and positive 2, 1, 2, 3, 4, negative 4. So this is our new line reflected across the y-axis. These 2 points and find the slope. So the change in y, negative 1 minus 2 over 1 minus 0. So it's negative 3 over 1. So negative 3 is our slope. And then we need to find the y-intercept. Again, the y-intercept occurs anytime x is equal to 0. So our y-intercept is happening at 2. So our new equation says y equals negative 3x plus 2. And like I said, there's another way to go about doing this. You can also change the x to a negative. So if my original equation said y equals 3x plus 2, I'm going to make x negative. So y equals 3 negative x plus 2. Go ahead and distribute that 3 to that negative x, and you get y equals negative 3x plus 2. And these equations are now the exact same. So if you remember, if you're reflecting across the y-axis, that your x just needs to be negative, plug that negative into the x and redistribute your equation. As long as y is positive, you're all set to go.